Welcome back to part 4 of Unit 0 Science Practices. This video will be talking about correlational research more in depth. By the end of this video, you should be able to answer the following questions. What types of conclusions can be made from correlational research studies? Why does correlation not equal causation? Can you identify the trends and connections between variables by using scatter plots? And finally, can you determine the strength of a relationship based on correlation coefficients? So let's just review from our last video what correlational research is. Again, correlational research gives us an idea about the relationship between two factors. We call those factors variables. Let's say, for example, we want to see if there is a relationship between the amount of sugar we eat and our energy levels. One thing that correlational research does not do is that we do not manipulate either of those two variables. We are not changing the amount of sugar that someone takes in their diet. We are also not changing someone's energy levels. We're just seeing, is there a relationship between the two? Because we're not actually manipulating either variable, we cannot determine cause and effect. Two important things that I know I have said a bunch of times, but I'm going to say over and over again because it's super important. Correlational studies are not experiments. We do not get cause and effect from correlational studies. Please do not use the terms experiment, independent variables, or dependent variables when we're talking about correlational studies. Correlational studies determine the strength and direction of a relationship between two variables, but we are not predicting the outcome of those variables. Last video, we also talked about one of the disadvantages with correlational studies, and that's the idea of illusory correlations. In order for us to truly assume that there is a relationship between two variables, we need evidence of that. If we don't have evidence, we can fall for the idea of illusory correlation. And this is when we perceive a relationship between two things when there actually isn't one. This persists because of confirmation bias and anecdotes. If we don't actually have evidence of that happening, it's not actually a relationship. Another example is the belief that when there's a full moon, it causes erratic behavior. However, there have been multiple studies done that have proven this to be incorrect. The problem is because people are looking for the erratic behavior, they are confirming what they think a relationship might be. And so we have the illusory correlation that comes about from a full moon and erratic behavior. Let's talk a little bit more about this idea of causation one more time. We did say that correlations cannot determine causation, but why? There are a couple of reasons for this. The first is because of a directionality problem. This is kind of like that argument, which came first, the chicken or the egg? We don't really know the answer to the question, and that's what happens with correlation. We don't really know which variable is causing the change in the other. We just know there is a relationship between the two things. We don't know if it's increased sugar that causes more energy or if it's more energy leading someone to eat more sugar. We don't know which is causing the other. In addition, there could be bidirectional causation as well. Sugar could cause people to have more energy as well as people with more energy eating sugar. Both of these things can be true, and we don't know which one is the truth without an experiment. One other reason why we can't determine causation is because of the third variable problem. A third variable is an unmeasured variable, we're going to call it C, that's impacting variable A and variable B. In our example of sugar and energy, maybe it's the amount of sleep that someone is getting that is actually impacting the amount of sugar that they're consuming and the amount of energy that they have. That third variable, sleep, is impacting both of the variables, A, sugar, and B, energy. And so this problem of a third variable leads us to not really being able to determine which is the cause of the relationship between these two things. Okay, so let's get into actually looking at an example of a correlational study. Let's say the two variables that we're going to talk about are the amount of hours someone studies per week and their happiness. A researcher is going to go out and collect data about each of those two variables. They're going to survey people and see how many hours per week they study. They might also ask students to give them a number out of 100 that would give them their happiness score. After we've surveyed all of our students, we've gathered data, right? We have quantifiable data. We have numbers that we can look at. We have the amount of hours that each participant studies, and we have their score, their happiness score out of 100. And you can see in this table, we have 15 participants. Now, we can look at that table and try and determine some sort of relationship between those two things, but it's pretty difficult for us to actually get any sort of idea of how these two things are related. So one way that we do that is we create a scatter plot. So what this means is that we take each data point and we graph it. So for example, our first student has studied 10 hours per week and they have a happiness score of 70. So what we would do is we'd find our 10 hours per week and we'd go up to 70 and we would put a dot right where those two axes intersect. In this case, it'll be right here. So let's go ahead and graph all of our data points. So here are our data points. You can see participant number 1 is right here. Once we have all of these data points graphed, now we can start to analyze this scatter plot and start to see patterns or trends that might come about from this data. In this particular case, we can see that our data points seem to start really high on the left-hand side of our graph and then start to get lower as we go toward the right-hand side of our graph. This is what we call a negative relationship. As one variable increases, in this case, the number of hours that they've spent per week studying increases, their happiness score decreases. So a negative relationship is going to be where one variable increases, the other decreases. And I like to use arrows to do that. So I'm going to do an up arrow and down arrow. So let's look at all of the different types of relationships that we can have in a correlational study. Here's an example of some of the different scatter plots that we can have when we plot data. The negative relationship that we had is down here on the bottom. We see that as one variable increases, our x-axis at the bottom increases, our y-axis is going to decrease. A positive correlation is going to be where both variables increase at the same time or decrease at the same time. So if we're using our study hours and our happiness, it would be as the number of study hours increases, so does our happiness score. You can see that there are different strengths from our scatter plot. A perfect positive correlation is going to be all right along a line of best fit. Same with our perfect negative correlation. Most of the time, that's not going to happen. Most of the time, our data is going to be dispersed a little bit along the line. The strength becomes how close together those data points are to that line of best fit. So a strong positive correlation would have all of the data points very close together, and our negative correlation would have all of the data points very close together. As we get further and further spread out, we're going to have a weaker and weaker correlation. The relationship will get weaker and weaker. Now we have this scatter plot that's over here, and you can see that these dots are completely spread out. There is no way for us to see really any pattern or any line of best fit. This would be no correlation or zero correlation. This means that there is no relationship between the two factors that we are looking at. Now you saw at the bottom of those scatter plots an R value. Our R value is our correlation coefficient, and this is the actual value that we get that tells us how strong and the direction of a relationship between the two factors. In AP Psych, you are not required to know how to find R. You are welcome to use a correlation coefficient calculator online. And so we're just going to talk about what these coefficients mean. So our correlation coefficient can be anywhere from -1 to +1. And this value is going to have two different parts. The first part is the plus or the minus, right? The positive or the negative. And the positive and the negative tell us the direction. Positive tells us that it's a positive correlation, meaning that both variables increase or decrease at the same time. As something increases, the other increases. A negative correlation is going to tell us that our variables have an inverse relationship, meaning as one increases, the other decreases. So that's the first thing that you're going to look at, is that positive or negative. And it tells us the direction of our correlation. The strength of our correlation comes from the actual value itself. So anything close to those ones, right, -1 or +1, means that we have a very, very strong relationship. Perfect correlation would be 1, either positive or negative, meaning every single time something increases, the other one increases as well. Perfect negative would be every single time something decreases, the other one increases. As we get closer to 0, however, the strength of that correlation decreases. Something with a R value of positive 0.2 would be a super weak positive correlation. So there is a relationship, it's just not super strong. We're going to do some practice of these in class so you can get a better idea of how we determine the strength and direction of correlation coefficients. Here are some examples of different R values and their scatter plots and how they would look. Over here on the left, we have a perfect positive correlation. That's an R value of +1. The next one is a highly positive correlation, or a pretty strong correlation, with an R value of +0.8. Then we start to get weaker, of a +0.3. Then we have 0 with no correlation whatsoever. And then we start to get into our negatives, our inverse relationships. So our -0.3 would be a low negative correlation or a weak negative correlation. Our -0.8 would be a strong negative correlation. And then R equals -1 would be a perfect negative correlation. So just to wrap up our video here, a couple of reminders. Number 1, correlational studies find relationships between two factors or variables. They do not, however, give us any information about cause and effect. And then finally, we gather information about the strength and direction of our correlations using scatter plots and our correlation coefficient.